Recording has started. Okay, so welcome everybody to the first Sherpa free lesson. So this one is going to be on the periodic table, and it's going to be taken by Hannah here. She's going to go through the periodic table. She's got lovely lesson notes, and she's also going to go through an exam question at the end. If you have any questions about the topic that we're going through, anything on the periodic table, or even anything related to chemistry that Hannah might be able to answer, let us know in the comment section, and then I'll be able to do a little Q&A at the end. Don't worry if you can't sit and watch the whole thing. It should only be 20-25 minutes long. It's going to be going up on our YouTube channel as well. And if you are on the Facebook live stream and you want to work along with it, you're able to pause the video, start it up again if you've got another question, whatever it may be, and you can work along with us. Okay, so that's enough from me. And if you do want to get some tutoring, have a look at Sherpa Online. You can see all of the information on the left-hand side of your screen. And if you do want to speak to one of our tutor experts, you can give them a call on 01628 337 590. Okay, Hannah, over to you.
Thank you very much, James. Hello, everybody. I'm Hannah. Nice to see you all. I've got no idea how many of you are watching me, so hello. I'm going to start by putting my whiteboard up. So as you can see here, today we are going to be covering the periodic table of elements. As James said, I'm Hannah. I did my GCSE Chemistry back in 2010, I believe, or 2009 actually. So it was a while ago, but I have still got that knowledge in there somewhere. And I've been looking over your syllabuses for the current day, so I know what you're expected to know nowadays, which always helps. After I did my GCSEs, I went on to uni and I studied medicine actually. So a lot of chemistry obviously came in very, very handy, but it's always good to go back to basics. So I thought, where better to start for our first live stream than the periodic table, because from there we can find lots of different information that can help us answer actually a lot of questions in your exam papers, perhaps more than you would first think. So let me go to the first slide. So we're going to start with your lesson objectives, and I've got a little exam top tip here, which is for when you're revising by yourself. Always, as a starting point, go back to your specification or your syllabus, they might call it, for whatever exam board that your school or your college uses for your subject. So make sure that you ask your teachers, what exam board are we using? Is it AQA, OCR, EdXL, whatever it might be? Make sure you're really up to speed on what that is. Because if you refer to your syllabus or your specification, pretty much tells you what you need to know. Obviously not the actual content, but it gives you item by item, to know, or for example, to give a brief overview of how the periodic table was developed. So you can then think, right, do I know that? You can check your confidence. Yeah, 10 out of 10, I know that. Or you can think, I'm going to go away and revise that. So that's what I've done for you today. We're going to go through these 5 objectives, which I've based on sort of different exam specifications. A lot of them are similar and overlap anyway. So for today, any exam board that you're working with, this will still be a really useful lesson to tune into. So I'm going to go over how the periodic table was developed, so a little bit of a history. A question like this would be really nice. It's just kind of a recall of knowledge question, so we'll go through that. We'll then have a look at the periodic table and we'll work out how we can use it to find key information about the elements that are shown on the table. So at first it might look a bit like a load of colours and letters and numbers and it's all confusing. It's actually quite organised, and if you know what you're looking for, you can get some really great exam marks just by sort of knowing the structure of the table and how it's all laid out. We're going to go over the first 10 elements in the periodic table just because it's always good to have them on the top of your brain, and this is something that's stuck with me since I did my GCSE. So we're going to quickly go over that. We're then going to go back to the periodic table and we're going to use it to work out how that tells us the electronic structure of each element. And finally, we're going to have a look at a couple of past exam questions, which I have got from literally the most recent exam possible, almost, from November 2020, I think. So we're going to have a go at a couple of past exam questions. I'll tell you how I would answer them and how you can make sure you're getting the top marks for any question that you answer. Right, let's start. So the first objective that we have, give a brief overview of how the periodic table was developed. So this is going years and years back in history. So scientists started to do research and they started to work out that actually there's a lot of elements in our world, in the world we live in. There are a lot of different elements, and they thought we need a way to organize this. So they thought, let's put it into a table. And they wanted to organize the table in groups or in rows or columns or some sort of method that meant that all the elements that were in each group had similar properties. So they first thought they would do this by the atomic weight. So the atomic weight is the weight of each individual atom of a certain element. So for example, one hydrogen atom or one carbon atom. So that was the method they first used. But over time, they realized that actually that wasn't quite working. A lot of the elements were being placed in groups that actually they weren't matching up with the rest of the elements in the group. So what might seem that, okay, all the elements in group 1 should have similar properties, actually some of them might not have. So they thought maybe that method wasn't the best way of going about it. And also way back when the periodic table was first developed, a lot of the elements were actually missing, which they didn't realize. They thought, oh, we know all our elements, we're going to put them on this table. Actually, there are a lot of gaps. So the big scientist and a big name to remember for your exam is Mendeleev. He was a scientist back in the day, many, many years ago, and he basically took the table to the next level. And he thought, actually, this needs moving around. So he did what they call some pair reversal. So he looked at, for example, a couple of elements next to each other, and he thought these would be better in the opposite groups. So he swapped them over. And he also figured out that there were a lot more elements to be discovered. So he left some gaps. He didn't name the elements, he just left gaps. And over time, the gaps were filled. So in summary, what Mendeleev did was the elements were still organized based on their atomic weight, but he also took into account their chemical properties. So what I mean by that is how the elements behave in chemical reactions when they're with other elements, what state they exist in at room temperature, so if they're a solid, a liquid, or a gas, things like that. And what that basically meant was that scientists of the future, when they went to discover these missing elements, they could work out sort of what they expected the properties of the element to be. So, you know, we think it's going to be in this group, we think it's going to be a gas, and we think it's going to be very reactive, for example. So that's Mendeleev, and he did a big bit of work with developing the periodic table. Years later, scientists discovered what are called isotopes, which basically explained why ordering the elements by their atomic weight didn't always mean that all the elements in a group ordered by weight did have similar properties. So I'm going to go on here and we're going to just go away from the periodic table just for a minute and have a look at a little extra learning point. We're going to think about what an isotope is. So isotopes are basically two forms of the same element. So all elements have a nucleus, and inside the nucleus are protons and neutrons. I could actually draw this for you. So we've got our nucleus here, and inside there we have protons and neutrons. And going around the edge, we have shells, and these shells contain the electrons. So isotopes are basically where an element has the same amount of protons as another element. So for example, carbon, 2 carbon atoms, they have the same number of protons. However, what an isotope would be is these 2 versions of carbon have different numbers of neutrons in it. Now, because neutrons are neutrally charged, it wouldn't influence the properties of the element as such, but what it would do is change the weight. So that is why when they ordered it based on simply the weight, they were finding that not all the elements had similar properties because they might be different isotopes, which would be because the neutron number was different rather than the electron number or the proton number. We'll go on to have a look at that in a bit more detail in a second. Basically, jumping up to the present day, the periodic table is now arranged in a very structured way. All the elements in a group have very similar properties, and it is done based on the electronic structure, so the protons and the electrons, basically. So that is our first objective. That is the history. If I was you, I would go away and I would memorize it as a timeline. We're going to have a timeline come up later, which actually came up in an exam paper. So even though that was probably quite a lot of information I threw at you, it's really nice, easy exam points, just a knowledge recall thing. So now, hopefully on my screen here, you can see the periodic table. So we're going to use the periodic table to find key information about different elements, which you might be asked in exams. And this can come up in loads of different ways in the exam. So it might not say, tell me about hydrogen. It might be a different question, but actually you need to look at your periodic table to find the information about hydrogen to then answer the question. And it works to your advantage because you always get a copy of the periodic table at the front page. That's another top tip. So elements are now arranged in order of their atomic number. So rather than their atomic weight, their atomic number and the number of electrons in their outer shell. So atomic number is the number of protons an element has. So if you remember that diagram I just drew, in the middle, you've got the nucleus, you've got protons and neutrons. Atomic number is the number of protons that are in that nucleus. And it is the same as the number of electrons which are in the outer shells. So let's go back. Well, let's read this statement and then we'll refer to the periodic table to understand what I'm on about. So all elements in group 1 have 1 electron in their outer shell. All elements in group 7 have 7 electrons in their outer shell. This means that all elements in each group have similar reactivities and therefore similar properties. So if we go back, this is group 1. All of these elements have 1 electron in their outer shell. So as we go down, the elements are increasing in their atomic number, which means the number of electron shells in total is getting bigger. So this row has 1 outer shell of electrons. This one 2, this one 3, and so on. And then the group, so we've got group 1, group 2, 3 is here, 4, 5, 6, 7, 8. That tells us the number of electrons in the outermost shell of that element. So for example, over here, we've got group 5. We can see nitrogen here. We can immediately see, okay, that has 2 shells of electrons and it has 5 in its outer shell. So how I'm getting that information? It's in the second row down. That means it's got 2 shells. And I'm looking at which group it is. That is a tiny number 5, or we can count across. So 1, 2, 3, 4, 5. That gives us a lot of useful information about nitrogen. And it also means that we know all these elements in group 5 down here, they all have similar properties because they all have 5 electrons in their outermost shell. Hope that's all making sense. So that's a little bit of maths for you, but those 2 facts I've given you about the outer shells and the number of shells, you can then tell me information about all the elements in the periodic table. Really nice exam questions if those come up. So name the first 10 elements of the periodic table. Put this in as a little brain break, really. I just learnt them off as a little thing. I just used to recite it. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. I've written that a little bit wrong there. Sorry about that. But obviously, as I said before, you get the periodic table in your exam paper. So you can just refer back to that. You might get a question about that, just getting you to check if you can use the periodic table and you can identify different elements. Again, quite a nice, easy question. So this learning objective is pretty similar to the one we just covered. But we're going to take it a little bit further now. So we're going to use the periodic table to find the electronic structure of an element. So a little bit of recap from what I've already discussed. So every atom of an element has a nucleus in the middle. Draw this out again. So we've got a nucleus here, and inside the nucleus are protons and neutrons. And then we've got our electron shells. And if you remember, the number of shells that we've got is determined by which period or which row of the periodic table an element is found in. So each shell can hold a different maximum number of electrons. So the shell closest to the nucleus, it can hold 2 electrons. When we draw electrons, we can draw them either as crosses or as dots. You would keep it the same. So this would be wrong. I'm just showing you that there's 2 different options, but you would need to do it either both dots or both crosses. Either is fine, it doesn't matter. The second shell can hold up to 8. So I won't draw them all, but we've got 1, 2, 3, 4, and so on. 5, 6 there, 7, 8. And as you can see, the third shell contains 8, and so on and so forth. Now, when electrons are occupying the shells in an atom, they always fill the shell closest to the nucleus first. So say we've got 3 electrons. We're always going to put 2 in our shell innermost to the nucleus first. So we're going to put 1, 2, and then we'd have 1 in the next shell. If we had 5, we would have 1, 2 in the first shell. Then we'd go to the second shell and we'd have number 3, 4, and 5. So we would have 2 electrons in the first shell and 3 in the second shell, and so on. Got an example here. So I'm going to do this one, and then I'm going to ask James to pop on for our second question, and he's going to give it a go. So if you're watching live and you want to pause and have a go, that's absolutely fine. If not, I'm just going to go for it. So if an element contained 15 electrons, how many would be in each shell? So I'm going to draw this out. So I've got the nucleus here, and I've got the 3 shells. So 15. So we know that there's 2 in the first shell. The next shell we know can take up to 8. We can fit 8 on there. So 1, 2, 3, 4, 5, 6, 7, 8. Total now we've managed to put 10 into our atom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 15, so we can still fit 5 more in our third shell. 1, 2, 3, 4, 5. Please excuse the drawing. It's very hard to do on a, I've not got my mouse with me, but never mind. And how you would write that structure, if it asks you what is the electronic structure of this particular atom or element, you would write 2, 8, 5 with commas in between. So first shell, second shell, third shell. So James, did you want to give this one a go? So draw the electronic structure of an element with 7. Go for it. I'm sure you can get it. Yeah. Yeah. So for that, yeah. Perfect. 2 rings. So our first ring can only ever hold a maximum of 2. So in the first ring, yeah, you're there now. Great. Well, yeah, that's fine. Yeah. No, that's correct. That's correct. We always fill the first shell first, so that's fine. So that shell is full now. We can't put any more in that shell. So we're going to move on to the next shell. How many electrons have we got left? Perfect. Great. Yeah. And do you know how we'd write that? Remember how I just wrote with the 2? Yeah. So what would it be for this one? Perfect. Lovely. Great. That's it now, James. Your work's done. So so this is basically just a recap of what we've just gone through. So the group number tells us how many electrons in its outer shell. So that is the column, the group. The period number, which is the row, tells us how many shells in total the element has. So, for example, sodium, it's in period 3, group 1. That means we know it has 3 shells and it has 1 in its outer shell. And that means that you could then draw that structure out for sodium, which you could be asked in this exam. Oh, sorry about that. Now, we also, if we remember back to what I told you earlier, the atomic number is the number of protons, and this is always the same as the number of electrons. So when we know the electronic structure, the structure of the electrons, which is this, basically we can add them all up, we get the total number of electrons, and that tells us the total number of protons as well. So as you can see, literally from where that element is written on your periodic table, you can get a lot of information about it. So this is what I mean. Something so simple as the periodic table, you can get you a lot of different marks in different places in the exam. And you can always think, if you're at a loss, you think, oh, I don't know, it's a question about elements. Always think, what can the periodic table help me with? Always have a look at it, because it might just spark some knowledge somewhere. So we've got a few minutes left and we're going to do a couple of past exam questions. So I've taken this from the November 2020 AQA paper. So I'm not copywriting it. I'm saying clearly here where I've got my question from. And it's all on their website as well. Any example, they always upload their past papers. So it's always a really good idea to go through those and to go through the mark schemes as well, because then you can see where they're looking to give you points. So this is what the question said. So it's about the development of scientific theories. Figure 2 shows a timeline of some important steps in the development of the model of the atom. So as you can see, it's asking about that history of the development of the periodic table, which was our first learning objective. So we're going up in time here from 1890 to 1940, and we can see different models and the discovery of different things, basically. So the first question. So Mendeleev published his table in 1869. That's important. He arranged the elements in order of atomic weight, which we learned about earlier. He then reversed the order of some pairs of elements. If we think back, that was because of their properties. He realized it wasn't really working out. It wasn't very organized. So a student has suggested that Mendeleev's reason for reversing the order was to arrange the elements in order of their atomic number. So explain why the student's suggestion cannot be correct. So if you're watching live and you want to give this a go, pause now, give yourself a couple of minutes. I always say a mark a minute, so it's a 2-mark question. So for those of you that aren't pausing, or if you're watching back on YouTube or whatever, obviously you can pause then too, but if you're not pausing, let's go through it. So what I did was I went straight back to figure 2. We're using figure 2. But remember that day, 1869. So if we think 1869 is way back before this timeline even begins. As you can see here, electrons and protons weren't even discovered in Mendeleev's time. So what this student is basically saying is Mendeleev reversed some of the elements because of their atomic number. Now, as you remember, atomic number is number of protons, which is the same as number of electrons. When Mendeleev was around, no one even knew they existed. So that's the answer, basically, because the student can't be right, because when Mendeleev was doing his work on the periodic table, he didn't know that protons and electrons existed. So he can't have been arranging them in order of their atomic number when atomic number wasn't a thing. So that is why the student is wrong. So if we jump straight, this is on the mark scheme. I've copied it straight off the mark scheme. So atomic number is the number of protons an element has. That would give you 1 mark. And as shown on figure 2, protons were discovered in around 1918. Mendeleev published his table in 1869, so protons were not yet discovered. So actually, that really wordy question, quite confusing sounding, all you actually need to be able to do is look at this figure, order some dates, look at this timeline, and figure it out. You also need to know what atomic number means. So that's a key definition there to always have in your brain. When I was revising, I used to like putting my definitions like down the side of the paper. So I've got like my atomic number is this, an isotope is this, highlight it, or if you're typing your notes, highlight. It's always a really good way, because if you've got those key definitions, that's really going to help you out when you're answering questions, especially if they're long ones like this and you're not quite sure where to start. So give the correct reason why Mendeleev moved the position of some elements. So, as I already said, he moved them so the elements in the same group had similar properties. So they were originally organized. This is the answer, by the way. This is the answer. It's only a 1-mark question, so give yourself 1 minute. And that was what he did. And that is a simple recall question, knowing the information I gave you way back in the beginning of my presentation. So as I said earlier, when Mendeleev was doing his work, the elements were organized based on their atomic weight, but he realized didn't really quite work out. Like, the elements were meant to have similar properties in the same group and they didn't. So that was why he switched some of them around. So there you go. That's a quick exam past paper question, and that would give you 3 marks. So that takes us to the end of our session. Thank you so much, everyone, for listening. I hope you found that useful. Obviously, you can watch it over again on YouTube, maybe pause it if I've talked a bit too quickly, make some notes. But yeah, any questions? James, have we got any questions in the comments?
Let me just show myself and actually speak this time. So it turns out when I was answering that question, I was muted, which is probably a good thing, because they wouldn't have realised.
I could hear you.
You could hear me, but they couldn't hear me, which is probably a good thing, considering how I was answering that question. But now I think everyone can hear me. We do have a couple of questions.
Right.
The first one is, can you just talk us through some of the properties that a typical non-metal element might have in the periodic table?
I can try. So that is a learning objective. Great question from whoever asked that. I know it's a learning objective because I haven't. I chose not to focus on that today, but it is a learning objective. So non-metals. So basically, in the different groups, we have different, like, all the groups have kind of different properties. So properties of non-metals, they'll all be quite similar. I'm just having a look. Can we go on to the next question, James?
Yeah, of course we can. We'll put you on the spot with that one.
Yeah.
So the other one that we have is, what happens to metal atoms during a chemical reaction?
Okay. So yeah. So basically, there's both very good questions, and they both link in quite nicely. So basically, metals, so they have 1 to 3 electrons in their outer shell. So when they've only got a little number of electrons in their outer shell, that makes them quite reactive. So they tend to lose their electrons during a chemical reaction, which is basically, that's how reactions happen. Obviously, I haven't really covered this today, but the amount of electrons in an outer shell of an atom basically determines how reactive it is. So the more full the outer shell is, the more stable an atom is. The less electrons in its outer shell, the more reactive it is. So the metals easily lose, they usually have 1 to 3 electrons in their outer shell. So these ones, and they are very reactive. And then the non-metals, they have 4 to 8 electrons in their outer shell, and they easily gain electrons during a reaction. So they will take on electrons from the elements or the atoms with 1 to 3 in their outer shell, if that makes sense. So that is definitely something for me to look over as well. And that is, I've kind of covered one of the topic objectives, periodic table, but then we go on to properties of metals and non-metals, and the transition elements as well, which are these ones in the middle. So great questions. Maybe some next time, if we do another live stream, I'll do the next section.
Excellent. And the last question we have is just a nice little fun one. What's your favourite element and why in this periodic table?
Oh, I like that question. Now there's one with a really cool name, and I'm trying to remember what it. I quite like this one, xenon, because I like the XE. I just think that's like quite a cool, like quite a cool chemical symbol. And I also like carbon, because carbon is the one where everything's based on carbon. Like when you're looking at relative atomic size, relative atomic weight, relative formula mass, that kind of thing, they use the reference point is the weight of a carbon-12 atom. So I think of that as like the core of the elements, and they're all kind of, without that, we wouldn't have a way to organize everything. So they're my two favorites. Probably a boring answer. There are some really cool names in there.
I don't think there's no such thing as a boring answer. I think that was a brilliant answer. Okay, so that's it. That's the first Sherpa lesson done. Thank you to Hannah for doing it. It was brilliant. I'm sure those that are watching are giving a round of applause, and I am as well. And so Hannah hopefully will come back and do another free lesson at some point in the future, and we'll actually go on to maybe some of those questions that were asked. In the meantime, next week we have another free lesson, which is going to be an English language exam question. So make sure you tune in for that one as well, especially if you're doing English. It's always good to just run through an exam question with someone else. If you want to check out Hannah's Sherpa profile and maybe have some one-to-one tuition with her, then you can do through the link in the comment section below if you're watching on Facebook, and then also in the description on YouTube. We're also going to be plastering, clips of this everywhere we can, and again, Hannah's profile will be in those links, just to make sure that go and show her some love, get some tuition sessions. She's had a really good time on Sherpa. I'm putting words in her mouth there, but hopefully she has. So last things last, if you are looking for some online tuition, as I said at the start, give one of our tutor experts a ring on 01628 337 590. So that's everything from me. I'll say bye, and then I'll leave the last word to Hannah.
Great, thank you, James. Thanks everyone for listening. If you've made it this far, well done. That is half an hour of revision done today. Go and give yourself a break, at least from chemistry. It's been really, really great to do this. I will definitely be back to do some more free lessons. And I would love it if you could reach out and contact me if you want any one-to-one. I don't just do chemistry. Like I say, I did a medicine degree, so anything getting into uni. I did my A-Levels, I did Spanish, I did psychology, biology, chemistry, maths. So anything along those lines, GCSE level would be great. Or getting into university, UCAS applications, anything like that. I love to talk, as you can probably tell. So we always have a bit of fun in my lessons. Just drop me a message and I'll get back to you as soon as possible. But thank you for watching today. I hope you learned something, and hope to see you all again when I next do a live stream. So have a great evening, everyone.
All right, cheers everyone, bye.